Right, so we've talked about diffusion, passive transport, and facilitated transport. All of these um, basically do not require any energy input because they go from high concentration to low concentration. So we know that in liquids and gases, etc., the molecules will move from their high concentrated area to their low concentrated area. They do this through Brownian motion because all the atoms inside the molecules are jiggling all of the time, and therefore causing the whole molecule to move slightly, and as they move they collide with each other and bounce away. But there's one other type of diffusion or movement of a substance that does not require energy, which is essentially a specialist form of diffusion. Now, this is called osmosis, and osmosis relates to the solvent, not the solute. So it's the water, not what's dissolved in the water, that does the moving. It does this because, as you know, cell membranes are semi-permeable, meaning that they're not permeable to anything. So big things like proteins, for example, cannot move through a cell membrane in normal circumstances. So if you have one side with a lot of protein on it and the other side with very little, the protein can't cross the membrane, so it's going to draw the water in the opposite direction to equilibrate, and this is what osmosis is. It's the draw of that water going in the opposite direction to equilibrate the concentration, in this case of the proteins on both sides. So I've just written on the board here just to emphasize the point. Osmosis is a special form of passive transport. Passive transport is movement across a cell membrane without energy input. It's the movement of the solvent, water, not what's dissolved in it. And this is because what's dissolved in it, the solute, cannot equilibrate because it cannot cross the barrier, which in this case is the membrane. Remember, when you're thinking about osmosis, the water is moving from the water's high concentration. Well, high concentration of water means low concentration of what's dissolved in it, a solute. And it moves to its low concentration. So still high to low, but it's the water we're thinking about now when we're thinking about osmosis. So that would be the opposite to what you would see normally if the solute could move. The solute would move from its high concentration to its low concentration. But in the case of osmosis, it's going from the hypotonic side to the hypertonic side. And I want you just to think about that, because we use the terms hypertonic to say a more concentrated solution than the hypotonic side, which is the less concentrated solution. So a solute would move from hypertonic to hypotonic. Water moves in the opposite direction because we're talking about the water, not the solute, so it moves from hypo to hyper. That's all I wanted to say about osmosis, and again, if you've got any questions, please don't hesitate to ask.